Hello friends, in this video I'd like to solve the following problem from Romanian District Mathematical Olympiad for 10th graders 2023, problem number 1. So it's a preliminary stage of Romanian Mathematical Olympiad, if I am not mistaken. We wish to find all real numbers x such that 2 to the power x minus 1 plus 2 to the power 1 over square root of x equals 3. Here is my hint for this problem. This problem is not very difficult. If you know differentiation, of course. Differentiate the left-hand side and see on which intervals our function is increasing or decreasing. So give this problem a try and I will see you in just a minute. Okay, so first of all, we need to assume that x is non-negative because we are dealing with square root of x. So maybe let's write it. We must assume that x is non-negative. And now consider f of x equals 2 to the power x minus 1 plus 2 to the power 1 over square root of x, for non-negative numbers, of course. It's differentiable, and we see the following. Derivative of f equals derivative of 2 to the power x minus 1, it's 2 to the power x minus 1, but by the chain rule, times natural log of 2, plus 2 to the power 1 over square root of x times natural log of 2, but again, by the chain rule, we have to differentiate 1 over square root of x, and the derivative of 1 over square root of x, it's x to the power minus 1/2, so it's minus 1/2 x to the power minus 3 over 2. And now let's maybe simplify it a little bit. We have natural log of 2 times 2 to the power x minus 1 minus minus what exactly? Minus 1/2 x to the power minus 3 over 2, 2 to the power 1 over square root of x. Okay. Now, we wish to find on which intervals this derivative is positive, on which intervals it's negative. First, maybe notice that if I plug in x to be 1, notice that f prime of 1, if I plug in 1, I have 2 to the power of 0 minus 1/2 times 1 times 2 to the power of 1. So it's 0. Moreover, notice that this function written in green, it's increasing. Strictly increasing. But the part written in red, it's decreasing. Why is that? Well, the first part, the 2 to the power x minus 1 is increasing, is rather obvious. Why the second part is decreasing? Well, because we have a product of two decreasing functions. X to the power minus 3 over 2, it's decreasing because of negative exponent. And also 2 to the power 1 over square root of x, 1 over square root of x is decreasing. So we have a composition of increasing and decreasing function. Everything is decreasing. So we have increasing function minus some decreasing function. So the whole thing is increasing, the whole thing. And we have a positive constant right here. So the whole thing is increasing. It's increasing. And that means, since the value of 0 is attained at 1, that means that f prime of x is negative for x's between 0 and 1, and moreover, f prime of x is greater than 0 for x's between 1 and infinity. which means in turn means that f itself, f is strictly decreasing on the interval closed from 0 to 1. We can safely close on both sides. And moreover, f is strictly increasing on the interval from 1 to infinity. And that means that at x equals 1, our function attains its minimum, its global minimum. So write it. At x equals 1, function f attains its minimum. Is the only argument for which the minimum is attained. But what is f of 1? Well, f of 1 is 2 to the power 1 minus 1 plus 2 to the power 1 over square root of 1. Lo and behold, it's number 3. Exactly the right-hand side of our equation. So our equation can only have one solution, namely number 1. So all in all, the only solution of f of x equals 3 is x equals 1. And that closes our problem. Thank you for watching, and I will see you next time.